In this video, we're going to be talking about functions. So your functions foldable should be glued onto page 4 of your STAAR review book. So before we start looking at a few problems, I first want to go ahead and look at the front cover, and I want to talk about briefly how you determine if coordinates are functions, tables, mappings, or graphs. So first and foremost, remember that with functions, your x's can't repeat. And that's to put it simply. If you wanted a more longer definition, it is when every x is paired with a unique y value. So every x is paired with exactly one y value. You can't have one x paired with two y values. So before, again, we look at examples, I want to quickly go over coordinates, tables, mappings, and graphs. So with coordinates, we are only concerned with looking at the x values. So that would be 8, -7, and 6. Here we see that none of our x's repeat, so this would actually be an example of a function. So again, your x's must be different. So x's must be different. If you were to look at a table, in a table, again, we're only concerned with our x values. We are not concerned with our y values. So if you look at our x values, we have -2, 0, 2, and 4. We see that none of our x values are the same. They are all different. So this would also be an example of a function. Then, if we look at a mapping, so with a mapping, you have two circles, I guess, if you want to call them. You have your x's on the left and you have your y's on the right, and they are paired together by these lines. So what this is saying here is that I have -2 being paired with 1. So if you want to make this easier on yourself, you can also go ahead and write yourself ordered pairs. Then we have -2 being paired with 2. I have -4 being paired with 3. I ran out of room, so I'm going to go ahead and write on top. And then we also have -6 being paired with 4. So if we look at our x values only, we have -6, -4, -2, and -2. When we look at our x values, we do see here that we have x values that repeat. So this mapping would be an example of not a function. And a quick way to determine if a mapping is a function or not a function is to see if there is more than one of these lines coming from one x value. So here, if you see, I have two lines coming from one x value, and that automatically tells me that I have x being paired with two y values, which makes this not a function. Now, lastly, when we talk about graphs and if they are functions or not, we have to perform the vertical line test. So remember, vertical means up and down. So when we do the vertical line test, I'm drawing a line going through my graph. And since here I see that this only goes through my graph one time, this passes the vertical line test. Now, you need to do this in more than one part of your graph. So if I were to do it here, again, I see that it still passes the vertical line test. If your line passes more than one time, that would mean it is not a function. But here, since it only passes once, this is a function. So with that brief little review, let's go ahead and look at a few examples. And the first example we're going to look at is number 1. So number 1 wants to know which coordinates do not represent a function. So in order for it to not represent a function, that means that your x values will repeat. So looking at A, I have 2, 3, and -2. Again, I'm only concerned with looking at my x's. I don't care about my y's. Here I see that none of my x's repeat. I do see that I have 2 and -2, but remember, those are not the same number. So here, all of my x's are different, so this is a function. Looking at B, I have -2, 5, and 10. Here, again, I see that all of my x's are different, so this is a function as well. And again, if you're still unfamiliar on what your x values are, your x value always comes first. It's x comma y. We are only concerned with looking at the first number in an ordered pair. Then for C, I have 2, 0, and 2. Here I see that my 2's repeat, so this lets me know that this is not a function. Lastly, looking at D, I have 8, -7, and 6 for my x values. I see that they do not repeat, so this is a function as well. And the only set of coordinates that is not a function is going to be answer choice C. So now let's go ahead and look at number 2. So number 2, we are now looking at mappings. So we want to know which mapping represents y as a function of x. So again, that means which mapping represents a function. So here, looking at answer choice A, I'm going to go ahead and make some ordered pairs off to the side so we can compare them. So looking at answer choice A, I have -2 being paired with -4. I have -2 being paired with -1. I have -2 being paired with 3. And I also have -2 being paired with 5. I'm going to go ahead and write this up top because I ran out of room down there. So here I see that I have 1, 2, 3, 4 -2's as my x values. So that automatically tells me that my x's repeat and this is not a function. I could have also automatically said that this was not a function because there is more than one line coming from one x value. So then we're going to go ahead and look at B. So B, I have 0 being paired with -2. I have 1 being paired with 1. I have 3 being paired with 4. And I have 4 being paired with 4. So if we look at our x values, I have 0, 1, 3, and 4. None of my x values repeat, so this would actually be an example of a function. So here, B is your answer. But let's go ahead and look at C and D and determine if or why they might not be our answer. So looking at C, I have -3 being paired with -2. And I also have -3 being paired with 2. So here, automatically, without even having to continue, we see that we have x values that repeat, making this not a function. If we look at D, I have -3 being paired with -2. I have -1 being paired with 1. I have 2 being paired with -3. And I have 2 being paired with -5. So when you look at your x values, you have -3, -1, 2, and 2. Here we see that our 2's repeat, making this not a function. And again, you can recognize that this is not a function because you have 2 lines coming from one x value. So that was looking at mappings. Now we're going to go ahead and look at tables. So when you look at tables, remember, you are only concerned with looking at your x values. So for number 3, it says which table does not show y as a function of x. So we are looking for the one that is not a function. So looking at answer choice F, again, I'm only concerned with looking at my x's. I don't care about my y's. So I have -2, 0, 2, and 4. Here we see that none of my x values repeat, so F is a function. Looking at H, again, I'm only concerned with my x values. I do not care about my y values. My x values are 2, 4, 4, and 6. Here I see that the 4's repeat. So this is not a function since I have x values that repeat. Lastly, let's check G. Again, only looking at our x values. We do not care about our y values. So looking at our x values, we have -3, -1, 1, and 3. Now, some people might think that because I have -1 and +1 and -3 and +3, that this is not a function. But these are completely different numbers. -1 and +1 are not the same number. So here, since all of my x values are different, this is a function. So the only one that does not show y as a function of x is going to be h. Lastly, let's go ahead and look at graphs. So remember, for graphs, to determine if it is a function or not a function, you are going to have to perform the vertical line test. So for number 4, it says which graph represents y as a function of x. So we are looking for the one that is a function. So looking at f, I'm going to go ahead and start off by performing the vertical line test. When I draw my very first line, I see that it fails the vertical line test because it passes through the graph 2 times. So this is not a function. Looking at h, if I perform the vertical line test anywhere on this graph, again, it passes through more than 1 time, and this is not a function. Looking at G, here is the, I'm going to go ahead and darken the line. Here is the line that our graph is for G. So I have a straight vertical line going up and down. So remember, this line is made up of an infinite amount of points. So when I take my marker and I draw a vertical line going down, look at how many points it goes through. It goes through an infinite amount of points, making this not a function. So anytime you have a line going up and down, a vertical line, automatically know that it is not a function. Now looking at J, when we do the vertical line test, here it only goes through my graph 1 time. So here it passes the vertical line test. If I do it here, again, it passes the vertical line test. If I keep going here, it passes the vertical line test. If I keep going here, again, it passes the vertical line test. Anywhere we try and perform the vertical line test on this graph, it is going to pass, and that means that J is an example of a function. So here, J is my answer. It is the only one out of the graphs that is a function. So that concludes your functions foldable.